Hello everyone, let's look at Leetcode question 270, closest binary search tree value. At time of recording, this question has 1.8 thousand upvotes and 120 downvotes. Question is, given the root of a binary search tree and a target value, return the value in the binary search tree that is closest to the target. If there are multiple answers, print the smallest. Okay, so the input is the target and the initial root value. So in this first example, we have 4 as the initial root value, and the target is 3.7. The root value that is closest to target is 4. 4 is closest to 3.7. Okay, so the constraints are that the number of nodes in the tree are between 1 and 10,000, and the node values are between 0 and a billion. The target value then is between negative and positive a billion. So let's look at the examples in depth. Okay, so what this code does is first define the answer to be the initial root value. In this example, it's 4, and we loop a while loop for the root value and check the difference between the target and the current root value. Okay, so we find the difference between the target and the root value, and if it is smaller, if the difference is smaller than the current answer, that means we can redefine answer, because remember, we want to return the binary search tree with the closest value to the target. Okay, so we're constantly checking if whichever node is closest. And there's also an edge case that checks that if the two values are the same, we pick the smallest of the two nodes. We'll get that too in a sec, but we then have this other conditional that checks if the target is less than root value. Okay, this is important because let's say we find the difference and we redefine what answer is. What we then want to do, if target is smaller than the root value, this means that we can find potentially another node with a difference that is smaller than the current answer. So this means we would have to go for nodes that are smaller than the current node. Otherwise, we have an else statement that states if the target is actually greater than the current node value, then we want to find nodes that are greater than the current node value, because this would also mean that the difference would be smaller. If you have a bigger value than the current value, that just means that subtracting target from root value yields us a smaller difference. So let's run through this example. Okay, so in this example, we define answer to be root value. So answer is currently 4. We're at 4 here. So root value is 4 as well, because we start with root 4. And we then loop to the while conditional, and then do this check. If the absolute value of target, 3.5 minus root dot value, 3.5 minus 4 is 0.5. This is less than answer minus target, so answer and root are the same. 0.5 minus 0.5 is less than 0.5 is not true, and this conditional checks if they are the same. We then check if the root value, 4, is less than answer, 4. So since they're the same, we don't need to worry about this right now. So we just simply don't worry about this if conditional right now. 0.5 is the same as 0.5, the same difference, okay? So then we check this next condition, target, 3.5. Is that less than root value, 4? This is actually true. So that means that we can potentially find a difference that is smaller. So we do root equals root dot left. So this is 2 now, and then answer is still 4, but the root value is now 2. Okay, so we do the while condition again, and we check if the target, that's 3.5 minus root value, 2. 3.5 minus 2 is 1.5. Is 1.5 less than 0.5? Because that's what the answer minus target is. No, this is not true. So we don't redefine answer, and then we move to the next conditional. If target 3.5 is less than root, no, 3.5 is not less than root, so we do the else statement, root equals root dot right. Okay, so it becomes 3. 4, root value is 3. Okay, this is where it gets interesting. While root, so root is 3. We say if target 3.5 minus root value 0.5 is less than answer minus target, 4 minus target is also 0.5. Okay, so we check then this other edge case that says, okay then, since they're the same, we want the node value that's the smaller of the two. So target minus root is equal to answer minus target. So then, is root value 3 less than answer 4? It is, so that means we pick the smaller value. Answer becomes root value. Answer becomes 3. Remember, if you could see it here, if there are multiple answers, print the smallest. So 3 is the smallest. And then we do this conditional here again, and it says that the root equals root.right. Since target is greater than the root value, there's nothing to the right. We exit then the while loop and return answer. So answer is 3. Okay, let's check the solution. Very nice, so it works. The time complexity is O log n, where n is the number of nodes in the binary search tree. It's O log n because we're performing a binary search to find the closest value to the target. In each iteration of the while loop, we're either moving left or to the right child of the current node. This makes it so we're cutting the search space in half. So the number of iterations required to find the closest value is logarithmic, okay? It's log of n, O log n. And the space complexity is O of 1 because we're not using any additional data structures that grow with input size. So that's it for this problem. Thank you for watching.